So another challenge from Crunchlabs was to add a gyroscope to the IR turret. So I bought myself an MPU 6050, which you can find on Amazon in the link below for just a few dollars, and these things have a huge library of support. I wasn't able to get any footage playing with the kids because this is pretty sensitive. So we're going to use a common library to get some yaw, pitch, and roll values out of this thing, and then take those values and control our turret with it. Finally, we'll add a button to fire it. If you're doing this yourself and plan on playing with it, I highly recommend you buy some long DuPont wires like these, which is going to buy you a lot of flexibility.
We're going to start by wiring our gyroscope. Plug a red wire to VCC for power, black to GND for ground, one color to SCL and another to SDA. On the breadboard, plug your red and black wires into columns that are also red and black, SCL to A5 and SDL to A4. Plug in our breadboard to the PC and we're ready to start coding. Start by opening your library manager and searching for our gyroscope MPU 6050. I'm using the library from Electronic Cats, then click Install. Then go to File, Examples, MPU 6050, and select MPU 6050 _ DMP6. There are some notable pieces of code in our example, like the flag to display yaw, pitch, and roll, which we can then view. Let's build and upload this example to our board. If you see some gibberish in the monitor, like I have, then change your serial baud rate to 9600. The example requires you to send a message to the serial monitor before it outputs the values. Once you see some scrolling numbers, move the gyroscope board around and see if they change. To merge the IR turret code and gyro example, let's display both sketches on half the screen. Our goal is to move the relevant code from the example over to the IR turret. First, let's copy the includes from the example and paste into the turret code. Next, copy the code we were running, which actually gets and displays the yaw, pitch, and roll values. Paste this into the loop of the turret code. Copy and paste the if statements at the top of the loop in the example. With this much copy and paste, you should frequently go to Edit, then Auto Format to clean it up. Since we're working backwards, I'm going to write down the variables we're using for later. In the setup method, let's start by copying over the wire setup and the MPU initialization method call. Copy over the serial output for testing the connection, and copy over the MPU DMP initialization. Next, we'll need to copy the various offsets to get accurate values out. Finally, we'll copy over most of the body of the if dev status equals 0 statement. We're not worried about the interrupt code for our use case. The last body of code we need are the variables. If you recorded the variables like I did, then look for those and copy over into the turret variable list. Don't forget the MPU itself higher in the example code. Compile and run, then test it by moving the gyroscope and watching your serial monitor. Make sure to regression test the turret functionality as well. Before moving the turret with the gyro, we need to first remove code we don't need. This will be things like the IR code in the loop. We need to start by storing the yaw, pitch, and roll values as variables. You can copy the math from the print lines. Call and then make the yaw method, which takes in current yaw as a degree. I like to create a modifier I can set to scale the value of any math I'm about to write. The servo will accept values between 0 and 180, with 90 being no movement, 0 being full left, 180 being full right. We're going to subtract our current degree from the last degree to get the delta. Next, we want to bind that delta between the values of 0 and 180. If our delta is a 90, then write that to the servo. Finally, set our last yaw degree and add the variable to our globals. While testing, our turret only moved a tiny amount, so we can increase our speed modifier to 2. One more test and it works great, although at times it is getting a little squirrely on me. Now let's create the pitch method to control our vertical movement. This one is relatively simple. Let's store a potential next value as 100 plus the current degree. And then make sure it's bound between the min and max values already set up by Crunchlabs. Then write our new value to the servo, build it, upload, and test the up and down movement. We can move the turret, but we can't fire it, so let's wire in a button. We're going to connect ground to one corner of the button, and the other corner gets a wire to D2 on the Arduino. In setup, we're going to add a call to pin mode with pin 2 and the argument input pull up. This way we won't need any resistors in our path. We're going to digitally read that pin into a byte, and if that byte equals low, then fire our turret by calling the fire method.